Okay, so today what I'm going to go over is the cerebrum. This is kind of the bit when you think of a brain, all of the outer layer that looks a bit like mush. So this is the way I'm going to go about it is going to go through this image and label the different parts of it and what it all means, but with a bit of an intro to neuroanatomy in general. Neuroanatomy can get quite heavy, so I'm going to try keeping it as simple as possible, and then you can kind of go into however much detail and how deep you want to go. So starting off very basic, what is nervous system? Nervous system divides into two components. You have the peripheral nervous system and the central nervous system. The central nervous system is what we're kind of interested in. So this consists of your brain, like that, and spinal cord. So your brain, brain stem. Brain stem just links the brain and the spinal cord. So these different layers. The peripheral nervous system is just basically the nerves that kind of come out of the spinal cord, like that. And then this is our basic intro to what the central nervous system is. So staying basic, where is the brain? The brain sits inside your skull. How do we know? You can Google an image of like scalp, which is like an acronym, where basically it's like each letter stands for something, and it's like showing the different layers until you get to the actual scalp, until you get to the bone of the skull, the periosteum. So it stands for skin, then connective tissue, then aponeurosis, then loose connective tissue, then periosteum. So what we're going to start off with is we're going to imagine the skull, and we're going to talk about the meninges first, but we're going to imagine the skull as a box. So something like this. This is our skull. Fixed box, not going to change. You'll see that there's a hole here. This is the foramen magnum. This is where the brainstem and the spinal cord will be able to leave the skull. You obviously don't have your entire central nervous system packed into your skull, it won't fit. So you need a place for spinal cord to leave. And that is the foramen magnum, which is there. Then we need to have a brain. So I'm going to draw a brain like this. And this is our brain, like that. So, actually, let me just move it over. Okay, there's our brain. As you can see, that there's quite a lot of room between our skull and our brain. Ideally, we don't really want our brain just hitting and having direct contact with the actual bone of our skull. So what we're going to have are these things called meninges. Meninges are kind of like, the way I think of it is like clothing. So it kind of protects your body from the external environment. Meninges will kind of cover the brain like that from the skull. So think of putting a sleeve on from like a jumper or a coat, goes over your arm, meninges are like the sleeve. We will start with the outermost layer that's made up of three layers, dura, arachnoid, and pia mater. So start with the outermost layer. It's the dura mater. Mater meaning mother in Latin, so it's the idea of like, oh, close, and it's kind of like hugging the brain and the skull. Dura meaning tough. Then we have the next one, which is the arachnoid. Arachnoid meaning like spider. It kind of looks a bit like a spider. And then we have our final one, which is pia mater. And this is very, very close to the brain that you actually probably, it's very difficult to separate the pia mater off the brain. And each of these are the meninges. So meninges, you've probably heard of it through like meningitis. That's just inflammation of the meninges. And yeah, that can lead to different kinds of pathologies. One thing I'm going to talk about first, though, is we have this kind of gap between the arachnoid and the pia. This sits below the arachnoid, so it's going to be subarachnoid, and it's an empty space, so it's the subarachnoid space. And inside of it is this thing called cerebrospinal fluid. I assume you've probably heard of that as well, hopefully. Okay, this is CSF, and it sits inside the subarachnoid space. Okay, so where does this CSF come from? It comes from these cells in the ventricular system of the brain called the choroid plexus. These cells kind of produce this fluid, and then you have kind of these kind of ventricles that link and then kind of go down like that, it's a very odd diagram. It looks a bit like a duck or something maybe. Yeah, fluid is produced and it goes down, and it can go all the way down the spinal cord as well. And then after the end of the spinal cord, it will go into the venous system, and there'll be a constant cycle, and CSF is being produced all throughout the day. What happens now if there's some kind of problem and it gets blocked? Obviously, that means you're still going to be producing this fluid. You're going to get an increase of pressure on the brain, pushing out from this fluid as it increases. But the bot, like we said, the skull is like a fixed box, right? It's not going to be able to move. So what you get is this increased pressure on the brain. This isn't good. It causes problems. So this is what you do is almost like stick a tube up and drain it. This disease is called hydrocephalus, and it's something to watch out for. If you Google hydrocephalus, you'll see photos of what it looks like. But yeah, so that is kind of a quick intro to the ventricular system and the meninges. Next thing we're going to talk about is grey matter and white matter. So, probably heard of them. Grey matter and white matter. When you think of a brain before you start medical school, it's always drawn grey, like that. That's because the outside is filled with grey matter. Not filled, it is grey matter. And so what this grey matter is for is kind of like processing and cognition. This then forms the cerebral cortex. So the cerebral cortex is kind of this outer layer that you kind of see all over. It's really, really thin, it's only a couple meters thick, and it's made up of 6 layers. So each of them has different functions, and like each layer has different cells in. So this grey matter kind of does processing and cognition. White matter, on the other hand, that's then going to be on the inside of the brain. So kind of sitting like here, while this outside bit is grey matter. White matter, why is it white? Well, it's because it's covered in myelin. You've probably heard of myelin. It's the thing that kind of wraps around cells and increases the speed in which information can go down those neurons. So very simply, white matter things can kind of go quick. Grey matter, processing stuff happens. This is in the brain where grey matter is on the outside and white matter is on the inside. However, in the spinal cord, it switches. So the spinal cord, you have grey matter on the inside and white matter on the outside. We'll look at that now. So if you have a quick drawing of what a spinal cord looks like, what we're basically going to do, cross-section of the spinal cord. Spinal cord, you have different levels, right? Let's move that down. You have different levels of the spinal cord, so hopefully you should know them. So it's cervical, then thoracic, and lumbar, sacral, and coccygeal. And you have spinal nerves coming out of them. So cervical, you have 8, thoracic 12, lumbar and sacral is 5, and coccygeal 1. And this makes up 31 pairs of spinal nerves. What does this have to do with anything? Well, if we draw out roughly what a spinal cross-section of the spinal cord looks like a very general one, it's something like, that's not a good drawing. Something like this. Well, what you have is, like we said, you have grey matter and white matter. Spinal cord is the opposite to the brain, so it's going to be grey matter on the inside here, and then this bit outside is a white matter. White matter, we said, is quick, so the way I think of it, this is like this white matter on the outside. It's kind of like motorways. It sends information up and down the spinal cord really, really quickly. Processing and stuff kind of happens in the grey bit here. Where are we even looking? Like, what does this mean? If we kind of orientate ourselves, here you have dorsal part of it, and you have ventral. Dorsal meaning back, ventral meaning front. This bit is the spinal cord, and these bits are the spinal nerves leaving. The way we can kind of divide it, dorsal is related to sensory. So sensory information, what do we mean by sensory? If, for example, you put your hand on like a radiator, you feel that it's warm, that you're feeling that the heat from the radiator, that sensory information that will then pass up your arm, go to your spinal cord, and then go up to your brain to say, you put your hand on a radiator and the radiator is warm. That's what you're feeling, sensory information, like understanding the environment you're in. Let's say that radiator gets too hot and you want to remove your hand away from it. You then lift your hand up. How do you do that? Through motor. So that would be through the ventral. Here. Information from your brain will then pass down. So this will be descending now. It will go back down your arm to your hand to then move your arm or your hand off the radiator. So you're no longer feeling the heat. So we can kind of very roughly divide up this, where it's dorsal is sensory, ventral is motor. So it's going to have like alpha motor neurons and stuff. What you'll have as well is these kind of bits. Why does this butterfly shaped thing like this look like that? Each of these are called horns. Like I told you before, it's made up of grey matter, and here this is the dorsal component. So these are called the dorsal grey horns. Well, these at the front will be the ventral grey horns. So that's kind of how that works. In terms of ventral components, you have different kind of if it's all related to motor functions in the ventral component of the spinal cord, you have each of the nerves relate to different parts of the muscle. So you can kind of see how it groups together a bit. What I mean by that is kind of if we go more on the medial side of the spinal cord, you have like proximal muscles are controlled. Proximal meaning near. And then if you go a bit more kind of lateral, you have distal muscles. So this is, for example, like your arms and stuff versus your trunk. So proximal in the trunk, and then limbs and stuff like that in the distal muscles. Which makes sense, right? Because if distal muscles further away, more lateral in the spinal cord, versus proximal muscles, which are slightly more medial. Then you also have like flexor muscles and extensor muscles. So if you kind of divide them up like that here and here, the flexor muscles are more dorsal, so more further to the back. And then we have the extensor, which are more ventral. Yeah, so that's kind of a brief intro to how the spinal cord works. Information, like say sensory information, will enter through the dorsal bit. You might come across dorsal root ganglion, which is kind of like here, enters in. Let's say that information will go up to the brain. It's going to kind of enter through into the white matter, go up to the brain. Something might happen in the brain. Then it's going to come down, say in the white matter again. Then go to the ventral grey horn, and then leave like that. And that's kind of how it works. When I mean kind of going up and down in the white matter, what I mean by that, you'll come across this word called tracks. So tracks can either be, and these tracks, like I said, are kind of like motorways going up and down. These tracks just pass information up or down, and this information up and down is either sensory or motor. So it's either sensory or motor. This is what you'll kind of come across with most of the brainstem lectures that you'll probably have, and it can get a bit confusing. So sensory, something like spinothalamic. Spinothalamic, break down the word, spine and thalamic, like thalamus. So what this means is you're going kind of from the spine here and then going up to a structure in the brain called the thalamus. So it's going to be an ascending tract. Another kind of sensory one is going to be the dorsal column medial lemniscus, DC/ML. And that's also sensory. A motor tract is corticospinal. Breaking it down again, cortical, cortex of the brain, and then spinal descending down to the spine. So if you just break down the words, it makes sense what's going on. And these tracts are basically just like nerves, they're just nerves in the central nervous system. But yeah, hopefully that kind of gives a bit of an intro to a little bit of brainstem without getting into brainstem and spinal cord. Okay, now let's actually get onto the cerebrum of what it means. Here we have our cerebrum. Let's just move it here. And what we're going to do is just label it. So how do we go about doing any of this? Well, firstly, like I said, we have the brain sitting inside the skull. So all of this sits inside the skull. And then between the brain and the skull is this thing called the meninges. You'll have this thing called like the dura mater, which is one of the layers, so DAP, dura arachnoid pia mater. And what you then get is these kind of sheets. So one sheet kind of goes all the way like that, all the way down. As though, think of it kind of like a reverse mohawk. Rather than hair coming out, this is kind of going in. So your brain is made up of two hemispheres. So if I draw it out kind of like that, and then it's like joined by this structure called the corpus callosum. This is a really bad drawing, sorry. So yeah, this is your brainstem, spinal cord, and then it kind of goes in there, but it's just joined by the corpus callosum there. What you then get is this structure that passes all the way through, kind of like a reverse mohawk, and that is called the falx cerebri. And this goes down what this thing called the longitudinal fissure. Get into what that means. Yeah, you have another one called the tentorium cerebelli. Tentorium cerebelli relating to the cerebellum, which is this structure here, and tentorium relating to the word tent. So it's basically just a bit of dura that kind of sits and divides the hemispheres from the cerebellum. So yeah, let's get rid of this stuff now and start kind of understanding what we mean by the cerebrum. Cerebrum basically is all of this. We need to understand two words first. First being gyrus and the second being sulcus. So if we kind of zoom into the brain, what you'll have is divided. It kind of looks like this. Where you have these kind of big bits that clump together kind of, and then these gaps in between. So these gaps are called sulcus, and these bits here, gyrus. How do you remember the difference? So the grooves of sulcus, the U in sulcus, U like that, it's the gap in between. And then the gyrus has to just be the other one. So you need to understand sulcus and gyrus to then understand the way that the cerebrum is then divided. We'll start off labeling the different lobes of the brain. So the first one is this blue one here. This is called the frontal lobe because it's in the front. Frontal lobe basically does stuff like higher intellect, your personality, your mood, your social conduct, stuff like that. So where I remember it, like it's all at the front. That's the way what people see when they're interacting with you. They'll see your personality. They'll see if you're a smart person or not. They'll be able to tell your mood all at the front. So okay, next one. We'll go over to this kind of yellowy one. This is called the parietal lobe. This is kind of related to like arithmetic and calculations. Then you've got this green one here, which is called the temporal lobe. This is kind of related to like memory and hearing, where your ears, they sit at the side of your head, temporal lobes sits to the side. So this is hearing. Yeah, the reason why it's called temporal lobe is related to time. That's where people get like grey hairs normally outside their head there. So it kind of shows time, I guess. Maybe that helps you remember it. All of these, it's quite handy because all of the bones of the skull here are related to the lobes of the brain. So the occipital bone, the parietal bone, the frontal bone, the temporal bone. That then helps with the next one, which is the occipital lobe. Occipital lobe, this is related to vision. So if you've ever had a hit to the back of your head and you kind of like your vision goes all funny, that's because your occipital lobe has been affected. You do have another lobe kind of inside your brain, and that kind of this line here, we'll understand what this line actually is. But if you kind of open it up, where you can open it that way and this way, and look inside, there's this lobe called the insular cortex, and that's basically related to like taste, visceral sensation, like vestibular sensation, and that's made up of like a long and short gyri. But don't worry too much about that. This bit here, like I said, is the cerebellum. The cerebellum is related to like fine, like coordination and stuff, very important, but not going to talk about here. And then brainstem, it's made up of three things: midbrain, pons, and medulla. Full name being medulla oblongata. This is kind of basically what the brainstem does is like for life support as well. It's really, really important. And that's kind of this bit here. And like I said before, you have those kind of tracks and stuff going up and down. Information needs to get to the brain, and it has to somehow leave. That's going to have to go through the brainstem. And the way I can remember it is like an M sandwich, so MPM. Midbrain is at the top because it's close to the bit that I think about the brain, which is like the cerebrum, and then pons and then medulla. Each of them have different functions, and they look different to each other if you have a cross section of each of them. So what I'll say is try it when you start learning brainstem, understand and draw out each of the different structures of the brainstem. What's the difference between them? Where do the tracks that I was talking about up here, you'll come across the word decussate. Decussate just means crossover. That's the reason why when people say, oh, the left side of your brain controls the right side of your body, or vice versa, it's because there are decussations of these tracks, i.e. a tract going on the right side of the brain will cross over to the control then the left side of your body. Hopefully that makes sense. When you study the tracks, it will make sense. But yeah, that's basically the brainstem. Gonna get rid of it just for space though. Okay, we'll start labeling kind of the main sulcus first, because that makes it then easier to then label the gyri after. What you have is this one here. This one here is called the central sulcus. So this kind of goes on, this is kind of if you're wearing like a hairband on your head. Central sulcus. If you can find the central sulcus on the brain, you'll be able to kind of find your way around the rest of it. Then, and also these gyri and sulcus are very important because neuroanatomy can be a bit weird. You're like, how do you kind of divide up what looks like mush? It's not like normal anatomy. So the way to do it is literally these gyri and sulci. One way you could do it is through histology, and that's called Brodmann areas. Another way is through kind of function, so looking at different lobes and different structures like that. So, okay, going back, you've got the central sulcus, which goes like this. Then, like I said before, with the bulk cerebri, that kind of goes along here. That you have a longitudinal fissure that's going all the way down, and you can kind of split the hemispheres in half and then look in the inside of the brain with the corpus callosum. That's the corpus callosum is where the two hemispheres join together. The next one we're going to talk about is this one here. This is called the lateral fissure. Also known as the Sylvian fissure. There's going to be like different names and stuff for them, but don't worry about that. Okay, another one we're going to talk about is over here. And this is the parieto-occipital sulcus. You can kind of guess the naming because it's between the parietal lobe and the occipital lobe, and it's a sulcus, so it's kind of like the groove in. Then another one we're going to talk about. These ones are they're less obvious, so these ones like quite big. But the next ones are less obvious, so I'm going to do them a bit smaller. I'm going to go in the frontal lobe, like I said, like the higher intellect and stuff. And it kind of goes down like this. This is going to be the superior frontal sulcus. Superior because at the top, frontal lobe, sulcus, a groove. Then if you've got a superior one, that means you have to have an inferior one. So draw that like kind of here. This is the inferior frontal sulcus. After this, we'll go to the temporal lobe. Temporal lobe, like your frontal lobe, has superior temporal and inferior temporal sulcus. So kind of dividing here and here. Superior. Yep, and then after temporal lobe, we'll go to the parietal lobe, and you've got one here called the intraparietal sulcus. Going back to the central sulcus is quite important. If you go in front of it, i.e. this way, it's going to be known as pre. If you go this way, it's going to be post, it goes behind. So if we then kind of introduce all of that with the word sulcus, you have this thing called the precentral sulcus and the postcentral sulcus. So here is the precentral sulcus. Sorry, this is taking so long. And then here is the postcentral sulcus. Yeah. Okay. Why is all of this important? You kind of need to know how this all fits together and where each of the sulcus are, because then when it comes to the gyri are the actual structures, right? but you need to be able to know where to find them. So we'll do that now. Again, they've got fairly logical names. We'll start in the frontal lobe here. This is superior, it's in the frontal lobe, and it's now a gyrus. So this is going to be the superior frontal gyrus. If we have an inferior frontal sulcus, i.e. this line here, we're going to have an inferior frontal gyrus, which is here. And then you've got this kind of gap in the middle, and that's going to be called the middle frontal gyrus. Yeah, then we're going into the temporal lobe, and you can probably guess the naming system of this, so I'll shorten it down. Superior, middle, and inferior temporal gyrus. Okay, so superior temporal gyrus, middle temporal gyrus, and then inferior temporal gyrus. Then kind of going to the parietal lobe, you've got one here. This is the superior parietal lobule. And I didn't plan that one out well. The inferior parietal lobule. Okay, so now we kind of get back to the precentral sulcus and the postcentral sulcus. What do each of these kind of do? What do they mean? What's their kind of relation to this? So they also have a gyrus, and they have a name, and they have a function as well. So if we first label it, precentral gyrus, I'm going to put M1 in brackets and S1. What these mean, M stands for motor, S stands for sensory. And what this is related to is, this is related to motor function. This is related to sensory function. So if you Google an image of the sensory homunculus or the motor homunculus, you'll get this weird looking image where it will look something like you have kind of, if we're looking at 1/4 of the brain here, you'll have different kind of body parts kind of going down here. And each of those represent where the nerves going to that part of the brain are supplied. So for example, where does the nerves for the leg go? Where does it go for the hand? It kind of, if you see an image, it'll make sense. The reason why that's important is if, for example, somebody has a stroke, you're able to then work out what kind of pathology is actually there. Like what artery, for example, is affected based on what symptoms they're presenting with. Is it, for example, their arms are affected? Are their legs affected? Then you can kind of work out what's going on, where you need to treat them. So it's quite important, especially when it comes to stuff like strokes. Your speech, however, I will get onto later with strokes. Okay, there's a couple of others that we just need to go through. You've got these things called supramarginal gyrus and the angular gyrus. So just kind of here is the supramarginal. And then here you've got the angular gyrus. Okay, haven't really spoken about the occipital lobe. That's because at the back here, there's this thing called V1. V1 is the primary visual cortex. And like I said, if you get a hit to the back of the head, your vision is affected. This is why. Because information from your eyes will go all the way to the back of your brain in the occipital lobe. So going on to the thing about speech, I was saying, what you have are these two areas, one called Broca's and one called Wernicke's. You might have heard of them. They're related to language. Broca's area kind of sits around here, the frontal lobe, and it's Brodmann area 44 and 45. That's related to like histology, like I was saying. This sits on the dominant side of the brain. Normally, this is the left side of the brain, and so it's not on both sides of the brain. Normally, the brain is symmetrical, but certain structures will be on one side and not the other. Broca's and Wernicke's is an example of this. So, Broca's area, frontal lobe, dominant side. What this is related to is speech production. So if you just write that down. And then Wernicke's, this kind of sits kind of like here. This is the secondary auditory cortex. This is Brodmann area 22. And this is for language comprehension. So this is 44 and 45, and this is 22. And then this is language comprehension. So why is this important? Well, let's say somebody does have stroke. Let's say it's on the left side of the brain. One of the arteries on the left is affected. You can tell if somebody has a lesion in Broca's area versus Wernicke's area based on the way that they're talking. And how do you remember this? So Broca's area, if you take out the R, you have the word boca. Boca in Spanish means mouth. This is basically speech production will not be working. And so what does that mean? They actually can't get the words out. So it's going to sound very difficult, and they're going to get frustrated trying to speak. So Broca's is going to have like expressive aphasia. Aphasia is just when there's problems with their speech. Wernicke's, however, is different. It's about language comprehension. And so if somebody has a lesion in Wernicke's area, what they're going to have is speaking absolute nonsense. It's not going to make any sense to you. So how do you remember that? At the end of Wernicke's is que. Que in Spanish means what. I don't know why it's related to Spanish, sorry. Que means what. So it's like, if you're talking to somebody with Wernicke's, you're just like, what are you talking about? Because they might be talking about how the sheep jumped over the moon and took a spaceship on the back of a dinosaur. And it means nothing to you, and it doesn't make any sense, but to them it does. And so that's kind of the difference between Broca's and Wernicke's. And this is kind of why you need to understand neuroanatomy in terms of pathology. It can be a bit boring trying to get through it all now, but when you apply it to the pathologies, it can get quite interesting. But hopefully that gives you a bit of an intro to the cerebrum and a bit of an intro to kind of things like the meninges and spinal cord and brainstem.